All right, hopefully it's recording. Hopefully we'll find out soon enough. We're going to cover two sections today. The first section we're covering is 6.5. Now 6.5, the first theorem we're going to look at are these two here. Triangle longer side theorem. If one side of a triangle is longer than another, then the angle opposite the longer side is longer than the other angle. The bigger angle is opposite the bigger side. The triangle larger angle theorem. If one angle of a triangle is larger than the other, then the side opposite the larger angle is larger than the other side. The larger side is opposite the larger angle. The bigger side is opposite the bigger angle. So if we look at this first problem, you're constructing a stage prop that shows a large triangle, triangular mountain. The bottom edge of the mountain is about 32 feet long. So the bottom edge of the mountain is about 32 feet long. The left slope is about 24 feet. 32 feet. And the right slope is about 26. List the angles of triangle JKL in order from smallest to largest. So which side's the smallest? JK, because it's 24, yes? So the smallest angle would be? Angle opposite, which would be angle L. What's the next biggest size? 26, which would be angle J, which leaves us with the biggest side of 32. So the biggest angle is angle K. And that's it. Biggest angle opposite the biggest side, smallest angle opposite the smallest side. Any questions on this here? Let's look at the next one. List the angles of A, B, C in order from smallest to largest. So what's going to be the smallest angle? Because the smallest side is 11. What would our next angle be? And then C. We ready for the next one? So the biggest side, or the smallest side is 5.9. So the smallest angle is Q. Our next P, because it's opposite 6.1, and then R. So Q, P, R. Angle Q, angle P, and then angle R. Questions on this here? Well, I feel like we feel comfortable with sides, naming the angles from smallest to biggest, yes? Or we can go biggest to smallest, it's just going in the other order. List the sides of DEF in order from shortest to longest. Which angle is smallest? Do we know what angle F is? But what do we know about all three angles of a triangle? They have to be 180 degrees. So if I add 51 and 47 together, 7 and 1 is 8, 5 and 4 is 9. I can take that and subtract it from 180. 7, which would give us 10. 10 minus 8 is 2. 17 minus 9 is 8. So angle F is 82 degrees. So angle E is the smallest angle, yes? And what side is it opposite? So DF is the smallest side. What's our next biggest angle? And that leaves us with DE as the biggest. And that's it. Any questions on any of this here? All right, let's look at the next one. Well, again, they didn't tell us what the third angle is, but they gave us two of them, yes? Well, we can add these two angles together and subtract it from 180. Well, 0, huh? 120. And if we subtract 120 from 180, we get 60. And again, they want these in order from shortest to longest, so we need to find the angle that is the smallest, which is 59 degrees, which is opposite BC, so it would be the shortest side. Our next side length would be BA. And lastly, AC. And that's it. Questions on this here? Now, since we're talking about side lengths, we do need or segments, we do need the line segment symbol above each. We ready for the next one? We'll look at this one here, and then we'll move on to the next part of this lesson. So we want to list the sides of RST in order from shortest to longest. They already gave us all three. So which one is the smallest? ST, because it's opposite 29 degrees. And then RS. And RT would be last. So I know that there are other example problems that we have, but this is the last thing we're going to talk about in 6.5 is the triangle inequality theorem. Now what the triangle inequality theorem states is that the sum of any two lengths of a triangle is greater than the third side. So any two sides that we pick, if we add them together, they have to be bigger than the third side length for any triangle to work, for us to actually have a triangle. Now, what we'll look at first is trying to describe, is it possible to have a triangle? Well, not is it possible, but what the third side length would have to be. You're welcome. So in this triangle, we have one side length that is a length of 14, and we have another that is 9, yes? Now, as the theorem stated, that whenever we add the three side lengths together, two of them should add together to be bigger than the third, yes? So we know for certain that we need to have 14 plus 9 is going to be greater than x, yes? Because that's one of the ways that we can do it. But we could also have 14 plus x be greater than 9. And 9 plus x has to be greater than 14. Because no matter how we add them together, any of the two side lengths added together has to be greater than the third side, yes? Why do we not care about this one here? Yeah, 14 is greater than 9. There's no way that I could add a side length to it and it'd be less than 9. So that doesn't really tell us anything. Now looking at this first statement, well, we have 14 plus 9, yes? Which is 23 is less than x. 23 is greater than x. So really, whatever x is, it cannot be greater than 23. Because if it's greater than 23, well, those two side lengths added together would not be greater than the third side length. So we can't have it be greater than 23. Over here, well, we do need to solve for the value of x by doing what? Subtracting 9, because we're solving for x. We're trying to see what it could be. Well, here x is greater than 5. Because if x is less than 5, well, 9 plus 5 is not going to be greater than 14. So whatever that side length is for this setup here, it has to be what? So it has to be greater than 5, but what? So whatever that third side length is, has to be greater than 5, but less than 23. So no matter how we set the triangle up, that third side length is going to be between 5 and 23. If it is, then we do have a triangle. If not, then it's not a triangle. Questions on this here? Let's look at another one. A triangle has one side length of 12 and another side length of 20. Determine the possible lengths of the third side. Well, we can say what? 12 plus 20 is greater than x. Then we can say what? Greater than, and plus x is greater than 12. But we really don't care about that statement because 20 is always going to be greater than 12, yes? So that'll work. But it's the other two statements that we really need to be able to determine the values of x. Well, here, 12 plus 20 is, so 32 is greater than x. But the middle one here, we'll need to solve for x by subtracting 12 from both sides. X has to be greater than 8. So combining these two, we can say 8 is less than x is less than 32. So x needs to be between 8 and 32. It can't be equal to 8 or equal to 32. Because if it works out that it was equal to one of these here, it would actually just make a straight line. It wouldn't actually make a triangle. Any questions on any of these here? Smaller number is going to be to the left, bigger number is going to be to the right. Not normally, we don't do it that way. And it's mainly based off the fact when we look at a number line, if I draw this here, where are the smaller numbers? To the left, the bigger numbers are to the right. And that's how we set up most inequalities. We want smaller numbers to the left, bigger numbers to the right. Any other questions on this here? Do we need to see another example of one of these? Okay. Determine whether it's possible to construct a triangle with these three lengths. Well, what did we say? If it is a triangle, two of the lengths will always, added together, will always be greater than the third, yes? So looking at this here, 4, 9, and 10, well, we can say 4 plus 9 is greater than 10. Let's see, 4 plus 9 is 13 greater than 10. Okay, well, let's do another set. So 4 plus 10 is greater than 9. Is that going to be true? Well, yes, is 10 greater than 9? Well, yeah, it actually works out. This would be 14 is greater than 9. And we can try the last one, which would be 9 plus 10 is, so 19 is greater than 4. Well, yes. So can we make a triangle with these three lengths? Well, yes. Really, yes, because if one of these fails, it's not going to work. But really, because once we got the 10 on this side, it was going to work because it was going to be greater than the sum of the three. So let's look at the next one here. So 8 plus 9 is greater than 18. 8 plus 9 is 17 greater than 18? So can we make a triangle? No. We ready for the last one? 5 plus 7 is greater than 12. No, not a... This one here would actually work out to be a straight line. Questions on this here? So go on and copy this down. I will write it down on the board. All right, well, we're going to move on to 6.6. 6.6, the first thing we're going to talk about is the hinge theory. The hinge theory. And really what this is talking about is that we do have two lengths for this gate. This length and this length, as you open a gate, are they changing? No. But as we open the gate further and further, this angle here is getting bigger, yes? Because as you open the gate, the distance between here and here, this side length is getting bigger, yes? And really that's what this whole concept is if we have two angles or two side lengths that are congruent and an included angle, if two side lengths of one triangle are congruent to two side lengths of another, as we're opening the gate, then an included angle, the first, then the third side of the triangle is longer than the third side of the second. So here, since this angle, 88 is bigger than 35, then WX is going to be what? Bigger than ST. If we have two congruent sides and an angle in the middle, the bigger angle is going to be opposite the bigger side. The smaller angle is going to be opposite the smaller side. Not too far. And this here is just the converse of it. If we have two congruent sides and the third side is bigger than this third side of another, then the angle opposite the bigger side is going to be bigger than the other angle. So when we look at this here, well, the side in the middle is congruent, yes? 24 and 23, which side length is bigger? 24, so the angle, this angle will be bigger. So the measure of angle, so P ST is greater than the measure of angle SPR. That's it. Testing which angle is bigger. We're given these two triangles here. How does angle B, the measure of angle B, compare to the measure of angle E? Which side length is greater? The side length of 11, yes, so angle B has to be bigger, because the bigger angle is opposite the bigger side. That's it. Questions on these two here? So we do have the side in the middle that is congruent. Compare, how does JM compare to LM? Which one's bigger? Which angle is bigger? 64, so it has to be the bigger side. So we do have two sets of congruent sides, and we want to see how does AC compared to DC. Because of 48 is bigger than 47, so AC is going to be bigger. Questions on this here? If PR and PS are congruent, and then we do have this congruent in the middle, and we're told that QPR this here is greater than QPS. So this here would be the bigger angle. Which side would be bigger? Bigger side is opposite bigger angle. Smaller side is opposite the smaller angle. That's it. Questions on this here? So we have the same setup, but this time we're told that RQ is the smaller and SQ is the bigger. So which angle would be bigger? RPQ or SPQ? Would be this one here, yes? Bigger angle is opposite the bigger side, which would be angle SPQ. Bigger angle is opposite the bigger side. Any questions on this here? Too far. We're not going to worry about the indirect proof. What can you conclude about the measure of angle A and angle Q? Is greater, we could say because SR is greater than CB. Any other questions on this here? We'll not going to worry about that, but that is it. That is all we're doing for today. And that finishes chapter 6.